Hi, welcome to Light Lesson 2. Before we start, please take note that you need to note down the points in your notebook. So you need to watch the video once to take note of these points, and then after that watch the video a second time and pause to take any notes that you think is important. For today's lesson, we'll be covering the properties of light in our daily lives, which means I'll be giving you examples of the two properties of light that we have learned before. And also we're going to look at how we can look around corners since light travels in straight lines. And we're also going to look a bit at mirrors. So firstly, what are the two properties of light? We've learned in our previous lesson that light travels in a straight line and light can be reflected. Now, the example of light can be reflected will be in this example here, where you have an object and then you have your eye here. This will be your eye looking at the object, and so the light rays will come from a light source. So it will always come from a light source, and then you will hit the object, and then you reflect off the object and into our eyes. So that's how light can be reflected. And in fact, if you look around us, any object that is not a light source is reflecting light. So what are examples in our daily lives that we can use to show that light travels in a straight line? So the most common example will be the sunlight streaming in from your windows. If you take a look at the sunlight streaming in from your windows, you can see here in this picture that the light is actually traveling in straight lines. And this picture here is not so obvious, but you can see that the lighted area is the same as the window here, which means that the light comes in from the windows in straight lines here, and it doesn't bend around and goes all over the room. So therefore, only this part here is very brightly lighted up. And of course, if you go for walks in the parks and all that, maybe you'll notice patches of light on the ground or light streaming in from the canopy of the leaves of the trees. And so these are also examples of light traveling in straight lines. These are examples of light traveling in straight lines that we can notice around us. And if you ever go to watch performances where there are colorful light shows, then you notice that the lights that they use, the colorful spotlight that they use, will also show that the light travels in straight lines. Like in the pictures here. You can see that the lights in the picture, the light rays in these pictures from the different color lights are all traveling in straight lines. And of course there are also light shows, like the one indicated in this picture here, where there are powerful spotlights, and you can see in the picture that the lights projected by all these spotlights are also traveling in straight lines. And these are some examples from our daily lives that we can show that light travels in straight lines. Next, let's talk a bit about the reflection of light. From our previous lesson, we know that light can be reflected, and this picture should be quite easy to understand by now. We have light rays coming from a light source that travels to the bird, and then the light ray is reflected from the bird and it travels to the eye. And basically, different objects that we can see with our eye are reflecting light rays into our eyes. So each time you look at something, you can think about it and think about how the light rays are traveling from the object into your eyes, and how the light rays from a light source is traveling to the object and is being reflected into your eyes. But what happens if we place something in between the eye and the object? In this case here, let's say we have a cardboard or wall or something in between the bird and the eye. Can we still see the bird? Because the light ray that travels from the light source to the bird, and then the bird will reflect the light rays, and of course the bird will reflect the light rays in many directions. So if you are standing in different parts here, if you're standing here or here, of course you can see the bird. But if you're standing here, then you can see from the picture here that you will not be able to see the bird because the light rays that's traveling to the eye is being blocked. The light rays traveling in this direction is being blocked. And here is another example. Let's say that we have two cars on the road, and this would be a building. And you can see that the light rays from this car is being blocked by the building, so it cannot travel to the building, which means that the driver in this car here will not be able to see the other car. And so what can we do so that the driver in the yellow car can see the white car, for example? So we can have a clue by looking at the picture here. And of course in this picture we can see a mirror, and you can see that the mirror is actually reflecting the other parts of the road that is not shown in the picture, which means that we can make use of mirrors to help us to look around corners or to look at things behind us. And so by using mirrors to reflect the light from objects into our eyes, we can actually look around corners. And you can see from this picture here that the light rays traveling from the light source to the vase is being reflected by the vase into the mirror, and the mirror reflects the light rays into our eyes, okay, which where we're looking at the mirror. And similarly in the car example, we can actually put a mirror here. Okay, this is the mirror. Then the light rays from the car, let's say from the white car, would travel to the mirror, and then it will be reflected, and then reflected to the yellow car, so that the driver in the yellow car can spot the white car when it's moving around the building. So how do mirrors actually work? So let's take a look at an example. Let's say that we have a car. So let's make the car slightly bigger. Okay. And then let's say that we have a wall here. And of course the wall is in front of the car, so we can't see the car clearly. And then we'll be looking at the car from the other side of the wall, and so we can't see the car because the light rays that's traveling from the car is being blocked by the wall. So the light rays, the light comes from the light source, the car reflects the light, but the light cannot pass through the wall, so therefore the eye cannot see the car. So in order to see the car, we have to use a mirror. We can put a mirror, and let's enlarge the mirror. And once we put the mirror, we should be able to see the image of the car in the mirror, because then the light rays from the car can travel to the mirror, and then it gets reflected and it travels to the eye. And this is the same picture again, but I've drawn it in a different manner. So we have the car, the eye, and the mirror here. You can see the reflection. So what happens is that again the light comes from the light source, the object reflects the light into the mirror, and then the mirror would then reflect the light into our eyes. And one thing to take note is that this angle here and this angle here are the same, which means that if we were to move the eye here, we will not be able to see the car, and if we were to move the eye here, we will not be able to see the car as well. It's only when the eye forms the same angle as the car, then we can see the mirror. Then we can see the car in the mirror. And so that means that if we were to shift the car here, and the light travels in this direction here, and the angle is only like this, then in order to see the car, we need to shift the eye to here. And likewise, if the car is shifted over here, and the light ray is in this angle here, forming a large angle, then in order to see the car, the eye must also shift such that it forms the same angle. And you can easily verify this by going into your bathroom. Stand in front of a bathroom mirror and look at the reflection in the mirror, and then you try moving to the left of the mirror and then moving to the right of the mirror, and you notice that what you see in the mirror will be different. So for example, if you're in the bathroom, if you're facing the mirror, then you can move to the left, to the right, to the right, to the left, and you notice that the images that you see in the mirror will be different because the angle that you make with the mirror has changed. And mirrors are used in our daily lives for many things. Let's take a look at the examples here. If you go to a dentist, you will observe the dentist having this little mirror that is placed in your mouth, okay, to look at the teeth. Or if you go to shops, you might notice that some shops have this mirror placed on the ceiling, okay, which allows the shopkeeper to look at the whole shop. Or if you're in a vehicle, you'll notice that the cars and other vehicles have the side mirror as well as the rear mirror to observe cars moving from the side or the back. And then even for your torchlight, okay, you'll find mirrors inside the torchlight to help focus the light. And some of you might have seen this, where the policeman actually has a mirror to search under the cars for maybe dangerous objects or illegal objects. And not only that, mirrors can also be used, for example, in solar plants to generate electricity. So you can see lots of mirrors there which focus the energy from the sun into the towel to generate heat energy. And here's another example, a stove that is placed on a dish made of mirrors to help cook the food in the stove. And of course, periscopes, which allows the light or allows the person to see beyond the wall. Because the light travels in the periscope, it goes inside and then it goes into the eye. Can you think about how to make a periscope? Or how you can place mirrors in the periscope such that the light actually travels into the person's eyes?